I'm starting a basic differential geometry course. I'll explain the necessary concepts, important propositions and theorems. But I will not give any proofs for it. It's for tutorial videos. In this video, I will cover what is a curve, what is the arc length of a curve, what is reparametrization of a curve. Let me start with the definition of a curve. A curve is a function which takes the scalar parameter and forms a vector quantity. If t is the scalar parameter, gamma of t is a parameterized curve in Rn. It's a n-dimensional vector space. T can varies from between alpha and beta can take values from minus infinity to plus infinity. If we can construct a function of the components of the parameterized curve which maps to a constant value for all the values of t, then this parameterized curve can be called as level curve. For example, let's say gamma of t is equal to sine of t comma cos of t. A function sine square t plus cos square t gives the value 1 for all values of t. Therefore, gamma of t equal to sine of t comma cos of t is a level curve. If there exists derivatives of all the orders for n greater than 1, all the orders, then gamma of t will be a smooth curve. The first derivative of gamma of t is called as tangent vector. If the tangent vector of the parameterized curve is a constant value, then the curve will be a straight line. Now we will see what is arc length. If we have a vector v in a Rn, so it has the components v1, v2 up to vn. Its length is defined as square root of sum of the squares of the components. Let's take another vector u, and norm of u minus v gives the length of the straight line joining the vectors u and v. So let us take a curve gamma of t. Let's choose 2 points in it, gamma of t and gamma of t plus delta t. The length between these two vectors is given by the norm of gamma of t plus delta t minus gamma of t. When delta t is very small, the length becomes equal to the norm of the tangent vector. So the approximated length becomes norm of the tangent vector into delta t. Equation 2 is written as equation 3 when delta t is very small. So now I have to find the whole length of the whole curve. Then I will integrate this quantity from initial point to the final point. This gives me the length of the curve. So S of t is known as arc length of the curve. The derivative of the arc length of the curve gives the norm of the tangent vector. Thinking of gamma t as the position of the curve, so ds by dt will be the speed of that point in the curve. If gamma of t is a unit vector, then the tangent vector will be always perpendicular to the curve for all values of t. Let's define what is reparametrization. Let's take the two scalar parameters, delta t and t. From this we construct two vector functions, gamma tilde of t tilde and gamma of t. If there exists a map between t tilde to t as well as t to t tilde, if these two maps are smooth, then gamma and gamma tilde is called reparametrization of gamma and vice versa. A point in a curve, gamma of t is my parameterized curve. Any point in it is called as a regular point if the tangent vector at that point is non-zero. Otherwise, that point is called a singular point. If all the points in the curve is regular, then the curve is called as regular curve. Any reparametrization of a regular curve will be regular. If gamma of t is a regular curve and you choose any point in it, and that will be a smooth function of the parameter. A parameterized curve can always construct a unit speed reparametrized curve if and only if that curve is regular. Thank you.